In today's lesson, we are going to take a look at our scientific method notes. So our objective for this lesson is to be able to understand the scientific process through the use of the scientific method. And by the end of this lesson, you should be able to use the scientific method to conduct experiments. So we're going to start off by talking about what is science. So science is truly just a method for studying the natural world around us in order to gain knowledge through observations and then subsequent investigations. The scientific method that you are probably familiar with was credited, right? Its development is credited to Sir Francis Bacon. I think back in like the 16 or 1700s, Queen Elizabeth I era. But it was through his work that we developed this kind of systematic method of obtaining information so that it can be kind of reused by different people so that it's credible. So again, scientific method, right, is typically going to be 6 steps that are used to conduct an investigation. Now, you do not have to always follow this method. Think of it more as a framework or a guideline. However, the scientific method is incredibly helpful to kind of guide us in our thought process through a scientific investigation and designing an experiment. Okay, so it's really more of a framework. But typically the first step is to ask a question. And these questions often arise from observations that we make about the natural world. Now, an observation is anything, is a description of anything from your 5 senses. It is not an opinion, okay? So for example, you observe that the ground is wet. From this observation, you could infer or you could guess what caused the ground to be wet. It rained, okay? So observation and then inference. Now, making these observations and gathering this information typically leads us to ask some type of question, well, like what causes it to rain, or why did it rain here but not over there, right? And so these questions will help define the purpose of your lab or your investigation. Next step is typically to do some research or gather background information. So has someone already studied this question? Is there any information already available? But then you also need to ask yourself, is that information trustworthy? Is it not trustworthy? Is it from a reliable source? Okay, so doing some background information. And then step 3 is to form a hypothesis. Now, a hypothesis is simply a testable prediction to your question, okay? It is not an educated guess. Are you educated? Yes. Are you guessing? No. You just conducted background research, okay? It's not a guess. It is a testable prediction. Here we go. Testable prediction, okay? That is a hypothesis. It's not a guess, okay? You are using what you already know or observed to create your hypothesis, okay? So now you've got your hypothesis or your possible answer to your question. We need to test the hypothesis, and we're going to do that by designing an experiment, okay? So we're going to gather up any materials that we might need in order to carry out our experiment. Typically, we will conduct the experiment several times to make sure that the results that we get from our experiment are not due to random chance, right? We want to make sure that the data we collect is accurate and it is precise, okay? So typically experiments, they will be conducted, way more than 5 or 6 times. We're talking dozens, if not hundreds of times to make sure that the results are trustworthy and precise. So once you have created your hypothesis, you have tested your hypothesis, now you need to analyze the data from your experiment. So we're going to look at the data to see, does it show anything new? Does it show anything significant or important that we didn't know before? Okay. And we're going to take this data and we are going to organize it to make it a lot easier for us to read. Typically, that will include creating a graph or a table or some type of chart. Okay, because maybe we took notes during the experiment, maybe we collect any pictures or videos that were taken, but we want to make sure that our data is easily readable for yourself and for others who are going to be reading your analysis. Then finally, because we have organized our data, we can draw a conclusion. So we need to either confirm, support, or reject our hypothesis, okay? So we need a clear statement that says either the data does or does not support the hypothesis, okay? Right, does the data support the hypothesis? Our conclusion should also tell us what we actually learned in the experiment and who cares, right? What is the real world application for why we are doing this experiment? Your hypothesis is probably not going to be correct. Remember, it was your prediction about the possible answer. So if your hypothesis is not supported, that's okay, right? We learn even from wrong answers. So don't go back and change your hypothesis. Instead, think of new experiments you could do to retest your hypothesis. And that's pretty much the scientific method in a nutshell.